So this is my Alexa Raspberry Pi garage door opener, and I'll explain how it works. Now there's a lot of different ways I could have done this. Actually, this is the third setup I've had of this, and I might be able to do it with or without the Pi. And there's a lot of ways I could have done this, but this was just kind of fun and just entertaining, getting it working and figuring it out, setting it up. So if I come down here, I got my Alexa powered plug right there, and then an AC adapter. So when I set up a macro on my Alexa, that's where you can give it a series of commands. So I have it turn that plug on and then off to simulate like a garage door button press. So on the Alexa app, one of the issues I ran into is that I couldn't set a delay shorter than a minute between commands. So if I just had it go on and then off, it wasn't working. I really want it on, wait a second, turn off. But in the app, 60 seconds was the shortest pause. So Alexa's turning that on for 60 seconds and then off again. So basically this AC adapter, which is a 3-volt AC adapter, so that's going to be on for a minute and then off again. So when that turns on, if I come up here, it's plugged in up here. So power goes there. I've got a 220 ohm resistor to keep the current low. And basically the circuit involves this optocoupler right in the middle there. And what that's doing is when the optocoupler gets those 3 volts, it turns on an infrared light on the inside of it. And on the other side, which would be the right or the bottom half of that, it's closing a circuit. So basically I have one circuit that's controlling the other, and they're completely separate, which works out perfect for what I need. And the one reason I had to go with that device and not just plug the 3-volt AC adapter straight into the Alexa, straight into the Raspberry Pi, is that the 3 volts I'm getting from the AC adapter is an analog signal, and the Raspberry Pi is looking for a digital signal input. So I needed a way for the one to signal the other, but on a separate circuit. So that's why I used the optocoupler. That worked out great. So for a minute, the optocoupler is getting that signal, and it's putting an infrared light on. And then on the right side or bottom, there's a receiver, and when it gets that, it closes a circuit. So the bottom circuit's getting closed, and that's all connected. There's another 220 ohm resistor. That all gets connected to the Pi. So basically, when the Pi is putting out 5 volts, and right here on this the red cable, and then there's a sensor, which is the yellow. You can see that's connected to the optocoupler. So it works like this. The Pi is sending out 5 volts, and it's not getting anything back because the circuit is open. But when the optocoupler gets triggered, the circuit closes the loop, and now the Pi is getting back those 5 volts. So it goes, hey, if I'm getting back those 5 volts, it means the AC adapter's on. It means that the Alexa has been triggered. So now the Raspberry Pi knows, hey, I need to take action because I'm getting those volts. So I've got it programmed with a Python script, and I'll bring that up when I'm done this. And what the Python script does, it runs a loop, and it waits for that circuit to be closed, and it sends a signal to this relay, tells the relay, hey, trigger on. When the relay triggers on, that blue pair of wire, that gets connected. So the blue pair of wire gets connected, and that runs all the way along the basement out to the garage, and it runs to the actual garage door unit on the ceiling, and it's just simulating a button press. So out in the garage, if I trace the button where you can open the garage door, that the button goes all the way back to these two contacts up at the garage door unit. So I just ran this Cat 5 cable all the way out, and I'm running it to those same two contacts. So when that gets closed, it's a button press, and the garage door either opens or closes. And I think that's about it. I'll have to go out to the garage and show where that connects up. By the garage door unit, and you can see here my Cat 5 cable that runs all the way out, and you can see that blue pair. It connects to the two terminals on the very right hand side, because when you connect those two terminals for a second, that's a button press. So if I trace the cable, so what I did with the garage door opener, I traced the button. If I go to the garage, if I look on the wall there, there's the button on the wall with the wire. So I traced the wire all the way back to here, and I said, oh, it's connected to the two on the right. So I knew that, if I connected up those last two posts there, it would be the equivalent of a button press. So that's where I have the blue pair of wire goes. And there's my Cat 5 cable. It runs along the back of that, all the way over here. You can see there it goes. There's the side, and then that goes into the basement, and that's what runs all the way to the relay and the rest of the hardware that you saw inside. The basics of the Python script I'm using to control the garage door. It's a loop where it's waiting for the input sensor on the Pi to go high, and then when it does, it sends output to that relay where I have the garage door, where I have that blue pair connected. So the section I've highlighted here, if new state equals high, that's what it's looking for. So it says print garage, GPIO output on pin 4 is high, and that's what goes to the relay. Time sleep for a second and then low again. So I'm closing that circuit for a second, which is my button press. And then the new state gets set to low again. So the logic is set here in such that even though the Alexa is powering that adapter for a minute straight, obviously I don't want the garage door being pressed. I don't want the button being pressed for a minute straight. So that's why I have the logic in here that picks that out, and when it detects, it just sends a 1 second blip to that relay, and then the garage door gets triggered. And there's my script. Alexa, garage door.